So friends, when we are working with this, okay, we are working with factors. Thank you very much. Okay, now let's go back to where we were. Did we just work with polynomials? Okay, so let's go to the polynomial stage here real quick. All right, so put on here real quick, remember, okay? And put the following down for me. We have something like 3x squared plus 6y squared. The only thing you should need right now is just your notes and a pencil or pen, my friends. Now, what type of polynomial is this? A binomial. What is the degree of this one? This one can be really tricky. It's just 2, because it doesn't matter which term had the higher degree on this one. No, so this is just 2 is your higher degree. And would you guys agree with me? This is be the first term or one of the terms, and this would be what? Second term. All right, so this is term 2. Great. Now, remember terms are separated by addition or subtraction signs, not division or multiplication. Correct? That's how we knew the difference between our power properties and not our using our power properties. Now, I have a question for you. When you look at 3x squared, and it's going to be great today because construction's been going awesome outside the window here, my friends. Would you agree that we have some things that multiply together to make this term? All right, what 2 things multiply together? What do we have? 3 and what? An x squared. Okay, what do we call numbers that multiply together to get us a term? All right, so product is our end result. But what do we call the 2 things that multiply to get to it? And this I don't expect you to remember. Are you guys ready? Those are called factors. 2 things that multiply together to equal a number are the factors. Would you agree? And we're going to do factoring. Now, obviously this is a silly example, but what are the factors in this one? Yeah, 6 and y squared are the factors in the second term. So we're trying to basically break apart what got multiplied together. So factoring is unsimplifying. It's going backwards. And we have 4 different things you have to look for and do with factoring. We're going to do factoring today, and we're going to do factoring on Friday. And you should remember and know how to do all factoring as a result. I know this is putting pressure because this is going back to Algebra 1. Instead, we had geometry last year, Gregor, so we didn't factor all the time. No, we only did a few times. But this is stuff that you need to know. Okay, so friends, these are the rules for factoring. And the reason why we learned the number of terms with polynomials is because that signals how you're supposed to factor. Now, is everything factorable? And the answer is no. Okay, there's some things that are not factorable. Then we have other ways that we can use those later or to work with them. But you should always go through the steps. Now, I would say this a little bit differently, but I'm going to go like this. These steps, they go together. The first one, to me, is the most important one to work with. What's the first thing you should always, always, always look for when you are factoring? GCF. Remember the good old initials that we use? Our greatest common factor. Here's the thing. I'll tell you right now, there'll be a big chunk of you who won't do it. And then you're like, these numbers are really bad. And I'll look at you and go, they are really bad. Because you didn't take out a greatest common factor. You have to always do first. So always look for first. Now, here's the key. Regardless of the number of terms. Always, always, always do first. Now, you're going to hear me ask many times for the greatest common factor, and you'll be like, there isn't one. And I'll be like, yep. But if you don't ask it and get in the habit of asking it, guess what you'll forget to look for? The greatest common factor. So this is the number one thing you should always ask yourself. Can I take a greatest common factor out next? Then the next portion, I call it count the terms, okay? Because if you know the number of terms, you should be able to do this. So the next portion, you're going to count the terms. Because the number tells you what to do. Okay? The number tells you what to do. For instance, if I have 2 terms, okay, it tells you to look for 2 specific type of cases, okay? The factoring rules tell you if you have 2 terms. All right, so the factoring rules say to use, if there's 2 terms, look for difference of squares. Now, that was, remember we did those the other day in our extension one where it was something, I'll give you a quick little easy example of this. X squared minus 4, is that 2 terms? And is x squared a perfect square? And is 4 a perfect square? And difference means what type of rule? Subtraction. Or you're looking for the sum or difference of cubes. All right, and so an easy example of that would be something like x cubed minus 8, or you could have like an x cubed plus 8. Oh wait, didn't we also kind of do that last time? Basically, we created the pattern. Did we do lots of factoring and stuff? No. So when I have 2 terms, I go, okay, pause. Am I using a difference or sum of cubes? Am I using a difference of squares? And if it's one of those, then you apply it. Does that make sense? So it's like your first check mark that you look for. Okay, what happens though if you don't have 2 terms and you have 3? When you have 3 terms, what do? We factor using, and I call this a little bit of difference. I know like Ms. Patterson or Mrs. Prempos or Mr. Felinski might call it strategic trial and error, but I call it like logical trial and error. Or some people, logical guess and check. Basically, you say, hey, if this is a trinomial, I know trinomials are going to normally factor into 2 binomials. Now let's use logic to get my terms that go in each of my binomials. Again, we're going to review this, so don't worry if you don't remember every little bit of this. Are you guys with me on that? And then our last one. What in the world if I actually have 4 terms? Most of you are comfortable with difference of squares, or were. I don't know if you are anymore, but you were decent with greatest common factors. You were good with difference of squares. And honestly, you got pretty good at doing like logical trial and error, logical guess and check well with trinomials. It's the next one that throws you. I think it's actually easier. But the next one threw people off a little bit. But it is, are you ready for it? Factor by grouping is what this is screaming for you to do. Now, we're going to go through all of these, okay? Now, today, my goal is to get you through greatest common factor, also working with looking for difference of squares, sum or difference of cubes, and maybe starting logical trial and error. Notice I said maybe starting logical trial and error. But I want to get there because honestly, Friday, sorry, I'll get in the right class period. Friday, I want to be able just to finish the notes and just practice because this is one of those core, really important skills that we'll use all year and you use in every math class. The one last class you didn't use it that often in was geometry. And we even use it there once in a right while. So this is one of those skills. So are you guys ready? So when we go through this, I'm going to build as we go. We're going to start with greatest common factor, and then we're going to go with 2 terms, and then we're going to go with 3 terms. And that's probably about where we'll end today. Everyone with me so far? Okay, let's go for it. Now, when you do this, okay, and we're looking for the greatest common factor, what does that mean? Yeah, it's really exactly. What is the highest factor that divides out or undistributes? Are you guys with me on that? It's almost like undistribution. That divides out of all terms This is another reason why we learned exponents first. This is why we worked with our number sense and stuff first, because you're going to look at this, and really greatest common factor is undistributed. I'm going backwards. With me on that? So it's undistribution. So we're going to have parentheses when we work with this. Does everything have to have a greatest common factor? And guess what the answer is? Nope. Now, obviously, am I going to give examples of greatest common factors? Yep. We're going to do it that way. All right, let's see if we can do this one together. Okay, let's look at the first. And is it a polynomial? Would you guys agree? Okay. So what's the first thing you always ask yourself? Is there a what? Greatest common factor. So when you look at this, you got to look at the variables and you got to look at the numbers. Okay. So look at numbers first. Is there something that can divide out of both 10 and 5? What's the largest one? 5. Okay. Awesome. Now I also have to look at my variables in my two terms. And I have here 10ab, I got 5b. Then you ask yourself again, is there any variable that I can divide out of both terms? Which one can come out of both? B. So we then sit there and go, okay, I take a b out. Now, I just undistributed, right? I took it out. So ask yourself then, what if I take out a 5b, what's left for that first term? 2a, because what's 10 divided by 5? 2. All right, what's b divided by b? 1. So what's the only thing that we have there? Yeah, the 2a. Then we got to go minus. The minus sign did not leave, okay? But because if it left, we won't go backwards. One way you can check yourself if you're right, could you multiply it and know if you got there or not? Yeah. So what I'm going here is like, okay, what can I take out of 5b? 5 what? Well, 5b divided by 5b is, there you go. Now, how do you know if you're right? Could you check? Right? How would I check? Distribute. You go 5b times 2a minus 5b times 1. Oh, well, did that give us 10ab minus 5b? Do you see if you didn't have that minus 1, you wouldn't have that? So guys, did we factor it? So 5b and the quantity 2a minus 1 are factors of my original polynomial. All right, you guys remember doing that a little bit more? Okay. Let's see if we do the next one. Okay, we have another polynomial. What's the first thing you always look for? Greatest common factor. Okay, so I think we've got this down. Friends, what is the largest number that can come out? 15 and 35. All right, so we got a 5. I'm going to change here to 5. Awesome. Now, I want you to look at your variables. Now, do you guys agree with me that there is an a squared and an a? Can I take out the a squared? No, because end up we did it. You take out which one? The a squared or the a? And the way that you think about it is you take out the one with the smallest variable, can factor out of both. Because remember, it has to come out evenly, correct? So when I do, I can take out an a. Awesome. Now I have a b and I have a b squared. Which one can come out? Yeah, our b to the first. So I can take out a b, right? Now we have to think about, all right, what gets left? So now think carefully, what got left? Well, what's 15 divided by 5? If I took an a squared, an a from an a squared, what do we have? If I took b divided by b, which is 1, do I need to have it there? No, right? Minus, okay, let's do this next one. 35 divided by 5. What does that give us? Okay, now I have an a to the first divided by an a to the first, which is what? 1. So do I need to worry about it? No. All right, then I have a b can come out of b squared. What do we get left? See why we did exponents first? It just helps us do quick division and multiplication. So this would be the greatest common factor of that polynomial. Okay. Looking at number 3. How many terms do I have? And no way of combining them. Would you guys agree? Okay. No way of combining them. So if I'm asking you to factor, what's the first thing that you look for? Greatest common factor. Okay. So we look at it, we look at the numbers first. Is there a number that can come out of all three of those? So does the number move this time? No. Okay. Now we have to look at our variables. I have x squared y, I have an xy squared, and I have an xy. Can I take an x out of all three terms? What exponent? An x squared or an x? All right, it's always the smaller of the two exponents. Jack, I'm writing stuff down. You might need to know how to do this, correct? I know you're tired, but I am too. It's a crazy busy week, but I know you can write things down. All right, so we can take out an x. Wonderful. Okay, now when I'm looking at this, is there anything else I can take out of all three terms? What? Because I have a y to the first, y squared, y to the first. Well, the smallest one comes out, so it's y to the first. Okay. If we do this right, better have three terms inside my parentheses, correct? All right, so when we're doing this, what gets left on my first term? 3, right? Then I have an x squared y is divided by an xy. What do we have left with that one? Right? Because x squared divided by x is x to the first. Y divided by y is what number? 1. So it's left there. Now, the subtraction sign did not go away. Did anything happen to the 6? Nope, it stays. Awesome. Then we have xy squared. What can I take out? Can I take an x out? Can I take an x out? Yes. Can I take a y out? So what do I have left? So it's going to be here, just 6y, correct? All right, what do we get for our last one? We have 2xy. The 2 has to stay, right? So I got plus 2. How about xy? Did it divide out? Yes. So an xy divided by xy is just what? 1. Yes.
Are the signs just based on the equation?
There is no equation. This is an algebraic expression.
The expression.
Mm-hmm. Yep, you can just keep them. Now, there's times if they were all negative, I would factor out a negative. Like if they were every single one a negative, I'd be like, all right, a GCF of a negative blah, blah, blah is coming out. I would do something like that. But otherwise, it always stays the same until we get to other types of factoring. All right, but with GCF, that's great. Now, the next one throws people off a lot. How many factors do you see in this algebraic expression? Okay. I think I worded that more different. How many terms do you see in this? 2. Aren't these 2 terms? So there's 2 terms. Because what creates the terms? Addition and what? Subtraction. So I have 2 terms. So here's my question. What are my factors? What you're multiplying together, right? Guys, what's the factors of this one? An x plus 2 and a what? Would you guys agree with me with the square? What's the factors of this term? We got 5 and a what? X plus 2. Are you guys seeing where these are going? So here's my thing. Is there a common factor? What would be my common factor? It's an x plus 2. Yes. Because you guys agree with me? And how many of those do I have in each one that I can use? 1. Would you guys agree? Now, so think about how I pull this out. So my greatest common factor is really a quantity this time. That's what? An x plus 2. Then I still have parentheses here. What got left if I took one of my x plus 2's out? An x plus 2. Would you guys agree? And then we'd still have our subtraction sign. What gets left now? If I take out an x plus 2, what's left out of this one? 5. Now, here's the thing. We're in math. Should we always simplify? So our first one we'd have as x plus 2. What does it simplify to if I go x plus 2 minus 5? x minus 3. You do simplify with inside the parentheses like that, if you can. Now, that's harder. So don't throw it out just because you have a quantity being squared or cubed or anything like that. Are you guys with me? Should we try one more of those just to see what it's like? Let's do Mrs. Gregerson's another example. Yes? X plus 2 minus 5. I just simplified this, is all that I did. Yeah, you just simplify it. All right, let me try this one, guys. What if we had 4 x minus 5 squared minus, I'm going to go 8. This one's going to be a lot of fun. X minus 5 cubed. What's the first thing you always ask for? Greatest common factor. So what's my number that's the greatest common factor? 4. Would you guys agree with me? This is going to end up being 4. Is there anything else that can come out? Oh, very good. You guys saw it. Excellent. You see we have this x minus 5 being squared, but it's also being what on this one? Cubed. So really, what is the largest factor I can take out of both? It's going to be your what? X minus 5 being squared. Then you have these giant parentheses that we got to work with. Guys, I have a 4 times quantity x minus 5 being squared. What did I factor out? 4 times quantity x minus 5 being squared. So what gets left? A 1. Because if you didn't, if I distributed, would it not be there? So we have to have it there. And then what do we get here? Minus, now I heard someone say earlier, minus what? 2. And then what do we have? Right? Because I have that 20. Now, could I simplify that further? Now, I'm going to sit there and say, simplify further. But right now, that's not my goal for you to do. Right now, I want you to get in the habit of pulling out your greatest common what? Factor. All right? Does that make sense? And this right here, is that your GCF? Yes. Isn't it neat? All of a sudden, we were just in Algebra 1, Gregerson, you just gave me simple little things like variables and numbers. Now you're doing quantities. Yep, welcome to Algebra 2. Yes, ma'am. Because if you're undistributing, you're dividing it out. So that divided by that would give you what number? 1. Yep, that's where the 1 came from. Please erase. This would be one of those moments. Fine. Can we do this? Is this going to let me erase? Yay. It stayed there. Okay. Now, everyone remember greatest common factor. I've thrown a big loop on you. You feel pretty good. All right. Difference of squares is probably my favorite method of working with this. But here's the rules. In order to do difference of squares well, you need to remember a few things. Shouldn't you know your perfect square numbers? Mm-hmm. Oh wait, haven't we been working with perfect square numbers by simplifying radicals? Oh yes, so the last couple weeks. Also, remember any variable raised to an even power is what type of number? Perfect square, okay? Is a perfect square. So just want to make sure that you remember that because we're going to use that a lot. Now, the other key thing is you cannot use this with 2 terms unless you have a subtraction sign because difference means subtraction. So if this is one that you would do, what is going to be our pattern? We're going to use what's called the conjugate binomials, where you just go plus and minus, and then you go, what's the square root of a squared? A. And then you go, what's the square root of b? B. And to check it, could you oi and realize there's no middle term and you're awesome when you're doing it. So we will be working with those and checking that. Now, this is always what you should look for first. But remember, I need to have even exponents to do this. Yes, sir. Yes. All right, let's look at the next ones. These are easy schmeezy. All right, first thing I'm going to ask you, is there a greatest common factor? What? X squared minus 4. Is there a greatest common factor? Okay, that was much better. The yes was scary, all right? No, there's nothing there. There's no number that can come out of both terms. There's no variable. Now you do this. Count terms. How many are there?
2.
Then ask yourself, is this a difference of squares? And your answer is?
Yes.
And difference of squares factor into two binomials. One is a plus, one's a what? And then all you have to do is take the square roots of the numbers. What's the square root of x squared? What's the square root of 4? Woe is me. I love difference of squares. You guys remember doing these now a little bit more? Now, here's the thing. If that's a plus sign there, could I do that? It has to be what type of sign? It has to be subtraction. Very good. Excellent. Okay, let's try another one here real quick. What's the first thing you should always look for if the directions are factoring?
Greatest common factor.
Is there a greatest common factor? Count terms. How many are there? 2. So you're going to look either for the cubes or I'm going to look for the difference of squares. Is this a sum or difference of cubes? No. This is a difference of what? Squares. Great. Because it's subtraction, this is a square number, this is a square number. We know as a difference of squares, they factor into two binomials. We go plus and minus. And here's the thing. Don't move the variable's location. If the variable's at the end, leave it at the what? End. Just do the square roots. Guys, what's the square root of 49? Put it in the first spot. All right, what's the square root of 4z squared? If you flip-flop them, you've changed your algebraic expression. So you cannot do that. Are you with me on that? Cannot do it. All right, let's keep going. Difference of squares is a quick review. This is one that I think everyone likes. It's pretty easy. Okay, let's look at the next one. What do you do first? Greatest common factor. Do we have one?
Yes.
What is it?
4.
Yay! So remember, GCF. Whoops. GCF. I love this new OneNote so much. Okay. I know the sarcasm was dripping really bad there, wasn't it? All right. So GCF first every single time, my friends. Okay. So we take out what number? 4. So then I go 4y squared minus what? Z squared. Now, here's the question you ask. You're not done just because you did a GCF. Now you ask, looking inside the parentheses, can I factor more? And you're like, oh, there's 2 terms. I have to check. Those 2 terms, is that a difference of squares? So notice what still comes along though. The 4 doesn't come along. You're wrong. So just remember that. So, because it's one of your factors. So if you don't include the 4, you're missing a factor. Okay. So, no, it does come along. Yep, definitely does. Yes, sir.
I've got a quick question. So if you can you factor the equation and then take the GCF or
Yes, but guess what most people forget to do?
take the GCF?
So it's always better to do it first, because here's the other thing, smaller numbers.
Yeah.
If you're not really great with big numbers, always GCF first. It will save a lot of agony and pain later when you're doing this. But this is 2 terms. I agree with you. It is a difference of squares, so we got to keep going. You keep factoring until you can't factor anymore, but you always bring down your terms. Guys, what does 4y squared minus z squared go into? What do we get? 2. And then what? Yep. Then you ask yourself one more time, can I go further inside my 2 parentheses? In this case, it's not a difference of squares or sum or difference of cubes, so are we done? Yes. But you always have to ask before you're done, am I really done? Because a lot of times people stop too soon. Like, guys, I know people stop too soon because I teach them in pre-calculus, and the very first thing we review at the start of pre-calculus is factoring. So if you can't do that, that's not a good thing. So we got to make sure you have it. Okay. Loving this one right here. Okay. What's going to be my first question?
Greatest common factor.
Is there a GCF?
No.
Okay. How many terms?
2.
So we got to check for either sum or difference of cubes or difference of squares. What do we have?
Neither. Squares.
Do we have squares or cubes? Squares. How do I know it's a difference of squares? It's an even what? Even exponent. Even exponents are perfect squares. So when we work with this one, we're going to still start the same. A difference of squares goes into two binomials. We have, remember those are called conjugate binomials because they're exactly the same except for an addition and a subtraction sign. What is the square root of x to the 4? And we have an x what? Square. Okay, now here's my question. What's the square root of 1? Are you done? I would say 2/3 of you said you were. You just didn't say it out loud. Guess what? 2/3 of you were wrong. Because when you do this, you now have to look inside each parenthesis even more. So like when I look here, I asked the question on this one. 2 terms, is that a difference of squares? And the answer is what? Is it a difference of squares? No. So can I do anything with it? No. But I go over here, and I go, okay, is there a difference of squares there? Yeah, by the way, 1 times 1 is 1. So the fact is, that in blue is still difference of squares. So when I'm factoring this, I have to bring down this x squared plus 1, but the x squared minus 1 factors more. Keep going. Now, it's still a difference of squares. So can I go plus and minus? All right, what's the square root of x squared? What's the square root of 1? Now ask yourself, inside of those parentheses, can I go any further with any of them? No, then you know you're done. That's the way, like say if you didn't take out a GCF and you found one, take it what? Take it out. But that's why we still want to do it first. All right, guys, what do you think so far? Remember when? Not too bad, is it? Okay. Now, this is the brand new that you were barely introduced to the other day. This is the sum and difference of cubes, okay? Here's the way to learn how to do this. Memorize the pattern. Did everyone hear me on this? Memorize your what? Pattern. Okay? So when you were working with it, the pattern is exactly the same for either the difference of 2 cubes or the sum of 2 cubes. It's the signs that switch. Now remember we had 2 sayings. Soap or San Diego Padres, okay? Were the 2 different ones you could do. So let's write down the pattern and then we'll go from there. So what are the patterns when I have 2 terms that are either a sum or difference of cubes? Well, I'm going to use the version of soap to do this one, okay? Now, when you have a sum or difference of cubes, they go into a binomial and a trinomial. I know it's weird. We go from like 2 small terms to like two big things with 2 terms, like multiple terms. Now, when you're doing this tells you what to do with your signs. So when we're doing it, you still take the cubic root of a cube. What are you going to get? A, right? And you're going to still take the cubic root of b, which you get b. But you need to know what sign to put in there. S means what? Same. So what symbol are we going to use? Subtraction. Then, no matter what, you need to think about, I need to get to a cube. So my first term goes in is going to be an a squared, because a times a squared is a what? Cube. So now, what does the O stand for? Opposite sign. So what goes here? Because if this is subtraction, this becomes addition. And then you just go A times B. Then, what does AP equal? Always positive, which means what type of sign are we going to use? Addition sign. And then, guess what you do with that B? Square. Because again, at the end, if I was distributing this, the B has to multiply to the B squared in order to get a B cubed. All right, so this is same. This would be opposite, and this is what? Always positive. Now, the exact same pattern holds. Your signs are the only thing that are different when it's the sum of 2 cubes. So here's the difference between difference of squares and difference in sum of cubes. Cubes, I can have addition. Never can I do that with the difference of squares. So again, exact same thing. We're going to use our sign, my friends. It's going to go into a binomial times a trinomial. Okay? So, what are you going to do first? Your a and your what? You take the cubic root. But what do I put in here?
Or no, addition.
Addition, because it means what? Same sign. Then what goes next, because it's still the pattern? A squared. What goes in here? Opposite sign, so that's subtraction. Then what do you do with your two values? Just a times b. Yeah, a times b, right? Multiply them together. Notice you're multiplying these two together, right? Is what you're multiplying together. And then what's our sign next? Always positive, so it's addition. And then what's our last value? B squared. All right, remember doing this the other day, last Friday. So it's a little bit, not quite 5 to 6 days ago. Now, keeping those patterns, here's the thing. You just have to memorize it. That's the only way you can sum and difference of cubes. It's the one where the pattern really matters, but it works out really easy. So here's how I tell people to do it first. Put in your signs first. Then worry about the numbers. Are you guys with me? You have to stay with me here. You're in that world where focus was not up here. So, here we go. Awesome. Now, is there a greatest common factor? What do you ask for first every single time? Is there a greatest common factor? Then you ask, is it a difference of squares? And what do you say real soundingly? No. Then you ask, is it a sum or difference of cubes? Yeah, this is two perfect cubes. So right away, binomial times what? Trinomial. Now use SOAP to put in your signs. What goes in my binomial? Plus. What do I put in for my next one? Opposite. And then what? Plus. Now can I actually just put in my numbers? Yeah. Guys, what's the cubic root of x cubed? What's the cubic root of 8? 2. Now, these are what I worry about for squaring and multiplying. Right? What's the one I do first? You're going to have your x squared. Then what do we do with these two values right here? Just multiply them together. So it's 2x. And then what do we do for our last one here? Just 4, because it's 2 squared, right? So 2 squared gives me what? 4. So this is your squared, right? So just go ahead and square it when you're writing it. Yes.
Would it be fine if we put it in as 2 squared?
But then you'd have to simplify it one more time. So if this saves you writing, yep, I would go straight there if it saves you writing. Guys, was it that hard if you know the pattern? No. Okay, let's look at the next one. First of all, is there greatest common factor? Amen. No greatest common factor. So, when you look at this, is it a difference of squares? What automatically tells me it's not a difference of squares? The cube just destroyed that, right? It has to be an even number exponent in order to be a difference of squares. So that's gone. Okay, so then you ask, is it a difference of 2 cubes? Yeah, because isn't that just x being cubed and what being cubed? 3. Isn't that really what we're doing? So now it is. So we go, all right, binomial times what? Trinomial. Okay, should we be able to put the signs in? Okay, so when we put the signs in, let's do it with the numbers. Let's see if we can do it combined. Okay? What goes first here? All right, x. Now, what's my sign that goes here? All right, it goes subtraction because we're using s, right? Which means same. So it's x minus, and then we go, oh, what's the cubic root of 27? 3. Okay. Then what do we do next? Then we square whatever this first term is. So we square it. So we get x squared. All right. But we have to use opposite sign, correct? Which means what? Yep, addition. Plus for addition. I'll take the one on that. And then what do we put in the middle? 3x, because they multiply together. And then what's our last sign? So always plus, right? And then what goes in last? 3 squared, which is going to be what? Hard? No? Okay, well, let's take it up a notch then. Because we're like, no. We're going to take it up a notch. We can do it, guys. Okay, it's not gonna move because I did something wrong. Okay. Okay, no. Okay. Give it time. It reacts. Oh, he's saying haha to my computer. Like, I don't know what the deal is, guys. What's up with him? Wow. Okay. We're next one. Friends, is there your greatest common factor?
Yes.
Is there a number that comes out of 8 and 27? A number that comes out of x cubed and y cubed? No. I don't have a variable that comes out of both, correct? Okay. So then you're asked, how many terms? Is it a difference of squares? So where do we go next? Sum or difference of cubes. Is it a sum or difference of cubes?
Yes.
All right. In fact, it's a difference, Mrs. Gregerson. Thank you. Okay. So we know we have a binomial times a what? Now, this is where people kind of mess this up a little bit. Okay, and I have a feeling you're not going to because you're smart people. But when you're working with this, what is going to be my signs? Let's just put the signs down. What are you going to have? Subtraction, then what? Addition, and what? Addition. I love the fact it's just addition at the end. It makes it so nice every time. So, same, opposite, always positive. Beautiful. Okay. What's the cubic root of 8x cubed? All right, so basically, are we putting in a 2x right here? All right, because this is really a 2x being what? Cubed, okay? Minus what? Do you agree with me that's really a 3y being cubed? So we got 3y. Okay, now here's my question. Well, what do I put in for the first one? Because what are we doing? Aren't we squaring the first one? So what's 2x times 2x? Are you guys seeing that this time? So you go 4x squared. Careful. A lot of people would put like 2x squared. So be really careful that you are actually squaring our first term. This is what you're squaring. All right, now what two things are we multiplying together? 2x and the 3 what? So what's 2 times 3 times x times what? 6xy, right? Good. What about our last one? Yeah, it's going to be a 9y squared because what do we do here? We got a 3y that's being squared. So you got to square the 3 and you got to square the y. You notice it's not much harder, but it's easy to drop something on that. All right, you guys do the last one. You do the last one.
Come on. Give me a minute. Give me a minute.
Why are people lying? I don't understand why they're lying on this one. Come on, I don't understand.
No, Dad. Wait.
I think this one's really fun.
Wait.
No, but that's still like the same thing as going 2 cubed, x cubed, which is the same as going the quantity 2x and raised to the power. So you're going backwards. So think, you could rewrite that as 2 cubed, x cubed, which is the same thing as going 2x raised to the third power, right? With our x by power. So that's where that comes from. And so then you're squaring the 2x. That's where that's coming from. Now, out of curiosity, did anyone go, that's a difference of squares? Okay. Great thought. Go cubes if you can go cubes first. Are you guys with me on that? So, why? Because then it ends up being really messy. You don't want to do this to yourself. It is actually easier to do the cubes first and then worry about squares. You'll see where I'm going with this in just a moment. Okay. Are you guys ready to try this one? I gave you a little bit of time. I didn't want to give you too much time. We're almost hit the 45-minute mark. Okay. Quickly with this one, my friends. Stay with me. Okay? When we're doing this, do you agree with me this is cubes? I also want to look at you guys and say, yes, I see it as a difference of squares as well. But if you can do it as cubes, do it as cubes. Are you guys with me? I would really appreciate anyone who physically have their eyes closed right now will open them in class. Because the last thing it is, I will be answering their questions if they're not doing and paying attention in my class. Is that clear? I don't care how hot, how tired, or exhausted you are. You're still my student, you're still in math class, and you're not going to learn unless you pay attention. With me? Thank you, I appreciate it. Now, I look at this and I see no greatest common factor. You guys agree? I do recognize the difference in squares, but I also recognize it can also be a difference of what? Go with the bigger one and go cubes first, okay? So when we're looking at the cubes, still binomial, still going to times a trinomial, what are going to be the signs inside? Minus and then what? Yep, because this is same, opposite, always what? Always positive. Okay, guys, what is the cubic root of 64x to the 6th? This is really 4x squared being raised to what power? Third power. So this is really what? 4x squared? Would you guys agree with me on that? Okay. How about our y to the 6th? What does that go to? Y squared. Because that's really y squared being raised to what power? Third. Great. Now taking those are your A's and your B's. You should be really good. Guys, what goes into this spot right here? All right. That'd be, because we're doing what? We're going to the 4x squared and we're doing what? Squaring it. Great. So we get here 16x to the 4th. Okay. What do we do for our middle one? Change that here. Yeah, 4x squared, y squared. Beautiful. 4x squared, y squared. We just multiply the a and the b together. And then for our always positive, what do we do here? Yeah, because y squared being squared is y to the 4th. Awesome. Now, are you done?
No.
You have to, oh, I heard something. What? Do you guys agree with me that we're not done? You have to look at each one of them and ask this question. Can I go what? Further. Oh, look, I have 2 terms. Can I do anything with those 2 terms? It's not some difference of cubes anymore, but it is a difference of... So guess what you've got to do? You've got to keep on going, my friends. Now, the next one, you don't have to worry about. It's done. You got 16x to the 4th plus 4x squared, y squared plus y to the 4th. Great. Nothing else you have to do there. But the difference of squares, you have to do. If you don't go completely, you're not done. Guys, well, what's the square root of 4x squared? What's the square root of 4x squared? 2x and 2x. What do we have? What are our signs? Plus and minus, because they're conjugates. And then what do we have? Y and y. Excellent. Now you're completely factor. Okay. Trinomial ones all of a sudden are starting to look really pretty after one like that. But all of those can get combined. All right, so here's what we're gonna take a pause. I think your brains are fried for the moment, and we're gonna go over your quiz. If I feel like your brains have turned back on after going over the quiz, I might even just say let's go do homework, or we come back to notes. So right now we're just gonna stop here. Are you guys good with that? Okay.